All right, today we're jumping into React. You know, that JavaScript library that's kind of behind the scenes on so many of the websites you use every single day. We're going to spend the next 5 minutes or so really breaking down the core ideas, piece by piece. I mean, have you ever really stopped to think about it? How modern websites just feel alive? You know, you start typing in a form and suddenly a button lights up, or you're in a search bar and the results are popping up instantly. How does that even work? Well, it's not magic, but it is a really, really clever way of thinking about how we build things for the web. So the secret, it's a completely different way of thinking about user interfaces. And the tool that lets us do this, it's called React. In the next few minutes, we're going to unpack the big ideas that make it tick, starting with the absolute most basic building block of any React application. Okay, first up, what on earth is a component? At its heart, you can just think of components as the building blocks of your UI. They're like custom, reusable pieces, almost like you get to invent your own supercharged HTML tags. So check this out. On the left, you've got your traditional HTML. It's kind of like a jumbled pile of bricks, right? Just a bunch of individual tags. But look over on the right. That's the React way. We take those messy bricks and assemble them into a single, neat package we call a component. So instead of writing out a whole table of contents in raw HTML over and over again, you can just drop in this one clean, reusable tag. That is the power of components right there. So what is a component really? Like under the hood? Get this. It's just a JavaScript function. That's the whole magic trick. It's a special kind of function that spits out a chunk of your user interface, or markup. And the one big rule? Its name always has to start with a capital letter. Seriously, these are the Lego bricks you're going to use to build, well, everything. Okay, so building with static blocks is cool and all, but that's only half the story, right? To make our websites actually do stuff, to make them interactive, our components need a way to remember things. You know, like what you just typed. To do that, we need to give them memory. And in the world of React, we have a special name for that, state. But how does a component actually remember stuff? I mean, how does that search bar hang on to what you typed? Or how does a button know if it should be clickable or grayed out? The answer to all of that lies in managing this memory. So state, that's just the official fancy word for a component's memory. Now here's the really crucial idea. Instead of manually telling the web page what to do, like, hey, disable this button now, you just describe all the different looks your component can have, all its visual states. And then you just tell React, okay, show me this state now. Okay, let's look at a simple city quiz to see this in action. The first state we're in is the typing state. Pretty straightforward, right? You can type an answer in the box, and that submit button is active, ready to go. Okay, now the user hits submit. Boom, we instantly switch to the submitting state. And look what happens to the UI. The text area and the button are now disabled. We didn't tell them to disable themselves. The component's memory, its state, just changed, and the UI automatically updated to match it. And then finally, let's say the answer was right. The component flips into the success state. And look, the whole form just disappears. It's replaced with a success message. The entire UI has transformed, and it's all being driven by that one little piece of memory. And here's the really mind-blowing part. All three of those completely different screens, the typing, the submitting, the success message, they're all controlled by this one single piece of memory, just one variable, status. All we're doing is changing its value from typing to submitting and then to success, and that one change orchestrates the entire user experience. It's incredibly powerful. All right, so state is obviously super powerful. But you know the old saying, with great power comes, well, the need for some good organization. If you're not careful about how you structure your component's memory, it can get messy really fast and become a huge source of bugs. So, to keep things from turning into a tangled mess, the main goal is to keep your state as simple and minimal as possible. There are a few key principles for doing this, but we're going to focus on a really big one, avoiding redundant state. That's just a fancy way of saying, don't store information in memory if you can just figure it out on the fly. Okay, take a look at this form. See the problem? It's storing 3 different things in its memory: first name, last name, and full name. But wait a minute, isn't full name just the first 2 stuck together? That's redundant. You're creating extra work for yourself because now you have to make sure all 3 of those pieces of memory stay perfectly in sync. And trust me, that's just asking for bugs. The much, much better solution is to only store what you absolutely have to. In this case, that's just the first name and last name. Then you just calculate the full name whenever you need it, right when the component is drawing itself on the screen, or as we say in React, when it renders. This is way simpler, way cleaner, and a whole lot less likely to break. Okay, but what happens when your apps get bigger? As your components get more complex, so does their state. Imagine you have tons of different user actions all trying to change the same pieces of memory at once. It can get pretty crowded and messy. Yeah, just think about a simple to-do list app. You've got logic to add a task, edit a task, delete a task, mark a task as complete. All of that code for changing the state ends up scattered all over your component. It gets really hard to follow what's going on and even harder to fix when something goes wrong. So to deal with this kind of complexity, there's a really neat pattern called a reducer. The big idea is to pull all of your state-changing logic out of the component itself and put it all into one single organized function. It basically works in 3 steps. First, instead of setting state directly, you dispatch an action that just describes what the user did. Second, you write this special reducer function that holds all the rules for updating your state. And third, you connect that reducer to your component using a React tool called the useReducer hook. And this quote really nails the change in thinking. Instead of telling React what to do, like set the state to this new thing, you just tell it what the user just did. You dispatch these actions. Your code just says, hey, the user added a task, or the user checked off item number 3. And then the reducer is the one that takes that information and figures out what the new state should look like. Okay, this all leads us to our final and honestly maybe the most important concept of all, purity. React is really designed around the idea that your components should behave like something called pure functions. So what does that even mean? Well, think about a simple math formula, like y equals 2x. If you plug in 3 for x, y is always going to be 6, every single time. It doesn't matter if it's Tuesday or if it's raining outside. A pure component is exactly like that. It follows 2 simple rules. 1, it minds its own business and doesn't go changing things that existed before it was called. And 2, if you give it the same inputs, it will always give you back the exact same output. Let's see what this looks like. On the left, we've got an impure component. It's causing chaos because it's reaching outside of itself and changing some other variable. The results are totally unpredictable and buggy. But the one on the right, that one's pure. It only uses the data it was given directly. Its output is completely predictable, reliable, and correct. And let me tell you, this is a huge deal. It means you can build and test your app one little piece at a time, and you can be confident that one component isn't going to secretly break another one. This whole principle is really the foundation for building stable, scalable apps with React. So there you have it. We've covered components, state, reducers, and purity. That's it. That's the absolute bedrock of React. These are the building blocks, the fundamental ideas that let developers create all those complex, interactive, and just plain alive websites and apps we use every day. So now that you've seen the tools, what are you going to build?